Hey everybody, we're doing another quick cluster design session, also to let Mike test out his fancy new headphones. Um, but yeah, I think I found, so what I've been working on is trying to find an encoding for the envelope type that works well at serialization boundaries, but also allows us to propagate the context that might be required by a message schema for serialization and deserialization, because effect schema, for those of you who don't know, does support running effectful transformations, where um, you can access the environment, and so that's you may actually have like environmental dependencies in your schemas. And so I think I found an encoding for envelope that's working well, but anyways, Mike and I thought it'd be good to just hop on and run through it, see if I'm missing something. So, um, we talked last time about how an envelope is basically just the address of an entity and the message that's going to that entity. And I was thinking about, what an envelope looks like at serialization boundaries. And I think that the first thing adjustment I made here is I made envelope a subtype of serializable, which basically allows us to use the serializable module from schema to serialize and deserialize an envelope. And you can basically like embed the schema directly inside the envelope, which is what's nice about the serializable interface. I'll kind of show what that looks like in a minute. But anyways, what
So
this type
basically, now the apologies. Now the envelope in itself is not serialized, so it contains the message rather than the serialized message.
correct. Well, uh, the deserialized envelope. So in a serializable, the first type parameter here is like the deserialized output type. The second parameter is the serialized input type, and then the third parameter is like any context that's required to serialize or deserialize.
Yeah,
Same.
I'm referring to the fields address and message.
Yeah, so the envelope itself, this interface here represents like the deserialized envelope. The encoded version, which I'll show in a second, represents what happens when you run like a serializable.serialize on an envelope. And the encoded version, if you notice, doesn't carry any information about the message. It's just the message field in the encoded interface is just unknown. And in addition, the address is the type of the encoded address. So we lose basically like all, as we should at the serialization boundaries, we lose all type information and we encode the envelope into something that's like basically JSON serializable. So the message becomes unknown and the entity address becomes like its uh, encoded counterpart. And to kind of like achieve this type signature up here, where now like if we have an envelope and we run serializable that serialize on an envelope, we end up getting the encoded version out. Uh, to do this, I had to declare a couple of different schemas. So I'm going to skip over the prototype and go to the bottom and talk about the different schemas that I declared. So the first thing I want to talk about is I kind of took inspiration from how Julio and Mattia and I had worked on a version of this before, but I kind of changed the way it works a little bit. But I took inspiration for declaring these schemas from how Julio defines schemas that take generic types in, so like either an exit, an option, and like all the schemas for those things. And we basically drop down to the schema.declare API. So here, this envelope from self type basically declares a schema that um, encodes. It's still an envelope here. Actually, I think this is, yeah, this is good. Um, this is basically a schema that represents an envelope and getting an envelope from itself. I still think I have to tweak some of these types because I think this is wrong. But
I think envelope from self probably has on both sides the same type, but I might be wrong.
yeah, I haven't written any tests for this, but I'm pretty sure you're right. I think this is supposed to be this. But I'm gonna leave it like this for now because I'm gonna be writing tests after this call. Um, but the
Always
point
a good
being,
idea.
yeah, well, especially when I'm doing stuff that I'm not fully sure works. But the idea here is that we can encode information about the message into this schema. And then similarly, I think this envelope schema here is actually declared correctly, where we essentially want to be able to declare the conversion between an envelope that contains a message and an envelope that's encoded. And this is the actual schema that gets embedded into the serializable side of an envelope. So I'll show what that looks like in a second. But basically, this envelope schema here is the important one where we have the message coming in, this message type here that comes in, and we grab the this is basically just the schema type for a message. Basically, just expands out the type parameters here. Um, and then we declare the encoded envelope type or schema here. And then we declare a transformation between the encoded and the not encoded envelope, where we can basically like use the different schemas that we have here to encode and decode between like the different representations of the envelope. So at a serialization boundary, this is the schema that's actually being used to do the conversion from like an encoded to a decoded and vice versa. Um, and then this envelope schema here is what actually gets embedded inside the prototype. Where is it here? For an envelope. Uh, so this serializable symbol here is what the serializable module uses under the hood to do serialization. And essentially, what's nice here is when we actually construct envelopes, when we use make and we create this prototype, um, we'll automatically get this serializable schema constructed from the message. Um, and so at boundaries where we actually need to do this transformation, it becomes really easy. We just call serializable serialize or deserialize. So, anyways, I wanted to show this first because this leads me to the point about um, what I think I've achieved in the sharding service that allows us to carry context to the appropriate places for the user. So what do I mean by that? I mean when a user declares a message type, we want to be able to propagate the context like requirements for that schema to the appropriate places. And so let me show kind of what I did. Maybe we can start with the interface for sharding as it is currently. So um, in the sharding service, there are a couple of additional methods, I think, since we spoke last time. Um, one of them being this make messenger method. This make messenger method is what allows you to construct a messenger that can then be used to communicate with an entity. And this is kind of the first piece. So when a when a user is interacting with sharding and actually needs to know about the context of messages that need to be provided, there's only really 2 points at which that happens, at least that I know of at the moment. Um, the first is when you are creating a messenger, because when you create a messenger, then that messenger can be used to send messages directly to an entity. Whether it's like a remote entity or a local entity is kind of abstracted away by the messenger. Um, but the point here is that when you create a messenger, this at this point you do need the requirements from that message are actually added, uh, like to this effect. So when you construct a messenger, it requires the context that's used to serialize and deserialize messages. And then the other place where this is added is when we actually register an entity. Um, and by adding the context for a message in these two places, um, I think I've arrived at something that is pretty nice from a usability perspective, like on the user end. Because uh, when a message, so the, on a given pod, right? When you create a messenger and you use the messenger to communicate with an entity, um, that's like one place where messages are being fired on off, right, to different entities. But the other side is like when a pod actually receives a message, and then you want to forward that message to like the local entity manager for that service. Yeah, Mattia, I think the serializable with result piece, I haven't decided if envelope should also contain the like result yet because we basically haven't talked at all about the client side yet. So that's why I haven't included like the success and failure context yet in these types, because we haven't talked at all about like what the client interface is going to look like or how it's going to work yet. Right now, I think we're focusing pretty much like on intercluster communication. We haven't really talked about like the client protocols. Eventually, we might need this to be not just the serializable context, but we may need to extend the envelope again with like the result types. But I think that conversation can be deferred, and it's pretty easy to extend these like context types later. Um, but anyways, the other place where the other side is when a pod receives a message, the pod needs to take that message and forward it to the appropriate entity manager. And to do that, it needs to deserialize the envelope, right? So the that kind of gets inside sharding, and I'll show like how it works. But inside sharding, I was kind of able to abstract that away. So let's take a look and kind of show what I'm talking about. So inside sharding, the first thing I want to show, so the messenger interface has not been fleshed out yet because ideally like a messenger would have the ability to ask and tell just like a normal client would, but um we haven't talked about like client communication or anything like that yet, which I just mentioned. So right now the messenger interface is kind of a stub inside here, but the point is the same. So when you register a messenger, when you create a messenger, you need to provide the context for the message, right? And then we can just grab the like inside this generator, we can just grab the context and then provide it anywhere where we actually like send the message. So
Uh,
when a
by the way, it might make sense to actually take a runtime to also propagate eventual, custom loggers and stuff like that.
I think that that's going to be what this turns into, but I wanted to start here because the other thing we might want to do is like allow for propagating not just like the serializable context, but any like custom requirements as well from like sending. Like we may want to extend this more. Basically, I think this should probably turn into a runtime. Like instead of grabbing just the context, like you said, grab the full runtime and then
Yeah,
use
I mean,
that.
it's quite literally the same signature, and you can provide a runtime, so not a big deal.
And then so basically the messenger, like I feel like this is nice because now when you actually send messages like ask or tell or whatever, you don't have to worry about any context. Like the context is dealt with, at least from the perspective of serialization for messages, the context is dealt with at the time that you're actually creating the messenger. You don't have to deal with it at the time that you're sending messages. um, so from communication with an entity, from that perspective, I feel like this is a real like a nice pattern, right? I think we've arrived at a nice pattern, at least for propagating context. And then what's also nice about this is we had talked before that no matter whether we're sending envelopes between the local, like no matter whether we're sending messages locally or to a remote pod, we still want to go through the full process of like serializing it into an envelope and then sending it off to the entity manager where the entity manager will deserialize. And we want that process to be the same regardless. And what's nice here is when we actually send a message from a messenger, we basically do that. We serialize the full envelope to get the encoded version, and then now uh, the envelope that we're working with inside the messenger itself is an encoded envelope. And if we look on the sharding service, there's this send envelope method that essentially takes an encoded envelope and either propagates to the local entity manager or sends it to a remote entity manager. So we like by doing this, we've essentially achieved um, the other goal that we had of making sure that no matter whether we're sending locally or remotely, we're always going through the full process of like serializing and then allowing the entity manager itself to do the deserialization.
I think Mattia is asking why additional context on the messenger client. Shouldn't that additional context be in the behavior instead? I mean, messenger should just encode and send over the wire and then decode back. I think that's
Yeah,
the context required to encode and decode. It's basically the context propagated from the schema.
yeah,
So
no,
most
and
of the
it's
time it'll be never, but given that
yeah,
schema allows for that.
yeah, and I mean Mattia's right. I think that any additional context would be like would be behavior related probably. The messenger context will be just pretty much only related to um serialization and deserialization or schema related. Any additional context would, from a user perspective, would only be relevant inside the behavior. So, so
But
yeah,
sometimes, especially like if we make a concrete example on when would you use that type of context. For example, let's say you have pieces of data that contains sensitive information that you want to encrypt and decrypt. You would probably pass down the keys through a contextual interface,
right.
some kind of stuff like that.
Yeah, and I mean when the behavior is registered, like when the so it brings me to my next point, so we can go there now. Um, so when an entity, so this is from like a messenger perspective, right? Because like when you're communicating with sharding, the two primary things you're doing, besides like starting sharding and like stopping sharding, the other two primary things you're going to be doing is registering entities along with their like the protocol to like their protocol and the behavior associated with that protocol. And then the other thing you're probably going to be doing is creating messengers, right? Those are like the 3 to 4 primary things you're doing with the sharding service. So we already talked about like creating a messenger and how we've kind of like achieved, I think, most of the flow that we're looking for there. I mean, there's obvious like refinements we can make here, but like the general like flow we were looking for, I think is starting to get there. The other thing you're going to be doing most of the time is going to be registering an entity, right? And when you register, right now, behavior is just doesn't have any context. It's very easy to add this into the type signature. Like I will do that at some point. Um, but
Quite literally forwarding an R.
right, but I wanted to keep it simple for the purposes of like the example here, where when you register an entity, the you're giving it the entity, the behavior, and any options related to entity registration. And this is the other place where, in addition to the R that we'll probably add for propagating, you just add this in for now. Just put never for the um,
By the
but
way, an interesting point now that I look at this signature once again, we could allow the behavior to fail with specific reasons. For example, let's say that the behavior decides to passivate himself. We could quite literally return an error from the behavior, and uh, the runtime would then detect that the behavior voluntarily passivated itself. Because like
yeah,
time out of that, if queue is empty, then I can passivate myself.
yeah, it's kind
That's
of
just an idea.
No, it's a good idea. It's kind of like what we do with stream with like the optional component of the error channel.
Yeah.
Where basically like specific error types might have specific behaviors associated with them, like if returned from a behavior. But getting back to the like
Or like Matthias said, return interrupted could
right,
actually be another.
um,
Why are we
the
overcomplicating things?
the other piece that I want, so basically um the other piece when registering an entity is that this is the other place where you would need to provide the serialization context for your messages. And what's cool about this, I think, is that now um, an entity manager, which is not exposed to like the client, it's an implementation detail. But by like doing it this way, the entity manager actually doesn't even need to know about in a global sense the type of message it's dealing with. It just needs to know about the entity it's dealing with because the entity has the message itself. So what do I mean by that? By doing it this way, I was able to remove the message uh, generic from the entity manager. And when we actually, so if I look at sharding again, and then I'll open the entity manager side by side. Um, in here, when we register an entity, we create the entity manager, um, and then we basically add it to the hash map of entity managers that we have here, these entity managers thing. And that's really all registration of an entity does for the moment. Um, but when we create a messenger here, the messenger um, basically checks to make sure that like grabs um, the correct shard from the shard assignments that we have registered to this pod. It serializes the envelope that we're passing in for this message, and then it basically takes the encoded envelope that we've created and the pod, and it sends the envelope to that pod. What does sending an envelope do? Basically, just checks if the pod address that we're getting is equal to the existing pod, then we send it to the local a local entity manager, the envelope. Otherwise, we send the envelope to a remote entity manager. Um, this is a stub for the moment, but sending to a local entity manager, um, basically all it does is, this check here might be somewhat redundant, but I'm going to leave it in there because I think it's good. Um, but essentially what we do is we grab the entity manager um, for the address inside this encoded envelope because the encoded envelope still contains the address details. So we can create an address using schema.validate to create an actual um, the constructed type of entity address. We can use that address to grab the appropriate entity manager, and then we can run entity manager.send and give it the encoded envelope. And then we end up, and that's basically all the shard manager is doing. We then end up in the entity manager where we run this send method here. I know I've got type errors, so it's just because my signatures need to be updated. But here, this is kind of like the important piece right here is when we create an entity manager, we can in the closure give it this like decode envelope um, function, which basically uses the entity schema inside the struct. And then when we actually send an encoded envelope to the entity manager, it just decodes the envelope, saves it to storage, and then sends it to the appropriate entity. So it's there's still a lot of like details that need to be figured out about like you know what should come back from saving a message and like when we send a message to an entity, what does it look like and all of that piece. But I feel like the serialization boundaries look really nice now, where like uh, the the type that's being dealt with primarily from the outside is like just it's a completely like generic encoded envelope where the message type is unknown, and the entity manager itself is dealing with decoding messages and getting like everything like that it needs from that message. So I feel like we're from the when we spoke previously, the requirements we had really were that we no matter which flow we were going through, we wanted the envelope to go through the full serialization and deserialization process. And I feel like we ended up uh we're 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 there now with this current design. But I mean, obviously there's a lot of details to be figured out from a behavior and manager perspective. So yeah, curious to hear your thoughts on this.
I think overall is nice. Clearly, we have to like. I like the new management um, of the envelope thing. It's better than the previous one for sure. Uh, as a suggestion, I was suggesting making it parametric on R, but making it parametric on the message makes a lot of sense anyway. And um, in regards to the rest, I think we need at some point to define, like, start to speak about the protocols and progressively remove stub versions in favor of concrete implementations. And I think we're gonna uh, discover more.
Yeah, I agree. Um like once I get the envelope communication to like finished up, I think the next piece I was going to start taking a look at is how the behavior is currently managed inside the entity managers or inside the entities.
And by the way, one thing I was noticing it, you have a check for the local shard, like mm, effect unless is on local shard,
Yeah.
and that checks for basically the entity being al- the shard of the entity being currently allocated to the pod. We also need to think about ring fencing of the shards, because we have to be sure that only one pod has a shard allocated, even if the pod goes bust. So this links back to the health checks that we were chatting about last time.
Yeah.
So
These shard assignments and unassignments is totally like unimplemented in the shard manager at the moment. That's another thing I have to take a look at. The other thing I have to take a look at is how the shard manager fits in with pod health because basically like in here this I mean you see this to do, but basically like this is an area where we should be probably checking if pods are unhealthy when we're actually trying to send to a remote entity manager. I'm pretty sure that's how it worked in the previous implementation as well. But yeah, I after having hacked on this a little bit, I think that I'm a little bit happier with how essentially like how the serialization boundaries are being managed for an envelope. Matthias said
yeah, it
that
makes a lot of sense because again, the first time um, that check I think needs to be in the entity manager inside the refs synchronized. I don't understand why it should be synchronized.
I don't I don't think it was even synchronized in the previous implementation, but
Leaks less possibilities, says Mattia. No, if the check is synchronous, there's no difference. It's basically over synchronizing. But yes, the final check is on the on the entity itself. I think we can, like, even if the message is sent to the local entity, at the very end the entity should always check, even the mailbox take should always check that the pod is healthy and the shard is allocated, so that the very moment we get deallocated from the shard manager, we are sure that we stop all the uh, basically we stop the shard locally.
Yeah.
Hi Dylan, we have Dylan on the chat.
Ciao, Dylan.
Ciao Dylan. I'm using same headphones that you suggested to Max. They're nice.
Let me see if there were any other questions I had actually while we're all here. Trying to think of the things that I was working on. One thing that I'm not like that I'm not like 100% happy about. I mean, I guess it's fine. It has to be this way. But ideally, this like send envelope thing would be an internal method on sharding, like something that's not exposed to the client. Should have a list of entity states in the entity manager where they are updated. That should have been a ref synchronized or a synchronized ref, so that updates and modifications are only in one place for the whole app.
Yeah. What I don't understand with this is, are the modifications effectful? Because if the updates are not effectful, but they're simply synchronous updates, then you don't need the synchronized thing.
Let's take a quick peek. So this is where I get or create the entity state, and this is well,
No,
I guess
that's
that
not
it.
that sure. What he's saying is that ensures no race conditions of having still the entity on the local assignments, but they are in an unassigning phase. I
I think
don't think
that
that.
the I mean, this synchronized ref here is where I'm creating the entity state. I also modified the type of entity state a little bit to keep it simple while we're like starting to iterate. But basically, like entity state at the moment is just two things. This is still very much not finished, so please don't judge. Um, but
Also, by the way, a very important element: the the shard manager should not deallocate a shard from a pod without the pod confirming the deallocation. So it should be, I'm gonna deallocate, then the pod does all the necessary work to shut down the behavior, and then only after the behavior is all the behaviors that are basically instantiated for that specific shard needs to be shut it down. Only at that point, the pod is gonna confirm back to the shard manager that it is deallocated, and then the shard manager can reallocate it again. The shard manager should not trust that the pod instantaneously deallocates everything. The only other case where the shard manager can take a decision by itself is if the pod is considered down. And if the pod is considered down, then we are back to the discussion of last time, which is that the timeouts when the downtime the pod considered down should be greater than the pod itself allows itself to be. Like the checks should be every second, and the pod should be considered down if the last 10 the
yeah,
last 10 checks failed.
right.
So some of those checks are redundant, and uh, this goes back to the the synchronizations locally. The issue with a synchronized ref is that all the reads will also, like, you can't have concurrent reads if your whole check is within the, like, it would consider everything an update. So it would be less performant. Maybe STM it would be a better primitive for this, but I think we can sort of defer to a later point.
Yeah, I think that the
Like
like the
Johannes
logic.
would say, I'm known for good points.
I think that the the like um the what's going on inside the entity manager definitely needs a lot of work. Um, at the moment, it's definitely it's not doing everything that it should be doing. For example, I still haven't incorporated your last point, Mike, about when like what's the last active time of a pod. It should be like the last time you finished processing a message, not the next last time you finished receiving a message, right? Um, but anyways, at least from the perspective of messaging, I feel like we're in a really good place in sharding. Like, I do think that propagating the message between like the external world and the entity managers, I feel like we've achieved like at least something reasonable and also reasonably type safe. Because like the 2 points at, or the few points at which a user actually needs to do something that concerns serialization, we're able to at least propagate that context to those points. So,
Yeah, I think overall it looks very very much on the right track.
so, um, but yeah, that was kind of like the main thing I wanted to show off is the new encoding for envelope. I do think I need to write some tests for envelope because I'm pretty certain, I'm like pretty certain that this is wrong, specifically this type here. Um,
No, I
but
think it should be type.
I think so too. Um, but I'm not 100% sure. I have to write a few tests.
But I mean, this is kind of an internal anyway.
Yeah, it's not this. I mean, we don't even have to technically export this, right? Like technically, this is the only one that even really needs to be exported, and even this envelope schema thing technically doesn't even really need to be exported because it sits inside the type. So everything here is technically internal and can be internalized. Um, but
Which, by the way, another small point. I don't quite understand these uh, serializable with the getter. Like, if we have an instance of the object, can't we just check the constructor? Why do we need a method? Like, the schemas are on the static side of the class anyway.
right. Mm.
I don't understand why we need the get serializable.symbol method, but this is beyond cluster. It's more of a point on schema and on the serializable trait.
Yeah, I mean, in this particular case, having it on the instance side is helpful because I'm using the message dynamically here. But
The schema itself is created with the message inside.
because message is a schema, right? Any message here, technically, like envelope.anyMessage is basically just a type alias for a tagged request and a primary key.
Got it.
Because
Then this is actually a good reason. That sort
yeah,
of answers why the getter instead.
and then I mean, yeah. So, um, so yeah, I'm pretty happy with envelope now. I hadn't been for a while, but now I'm kind of happy with it. I think through usage now it'll become clear whether this is good. And envelope as a type, like almost all the methods could probably be internalized, and we just expose the type. Because in reality, a user really shouldn't really be.
I don't think it ever surfaces the API unless you end up implementing yourself
Yeah, I
some
guess like
services.
yeah, because I do wait, the only thing I can think of is mailbox storage, but I'm pretty sure by the time it hits mailbox storage, you're dealing with the message itself. I
I'm
think
more thinking if a user ends up implementing um, a custom um, like a custom messaging protocol, communicate via WebSockets instead of HTTP, communicate via Kafka or really whatever.
That's
then
true.
probably they have to interact with that type.
Yeah, because the pods interface, which again is like literally just a stub at the moment, this this has the deals with the encoded side of the envelope. So if a user, I guess there are situations where maybe some method, but again, you're never the one constructing an envelope. There's very few methods that a user would actually need access to. But anyways,
We should probably only expose those
I know. I I
to
agree.
avoid,
I agree. Um,
subscribing to too much stability on the API. If the API is a single function, then we're stable day one.
Trust me, the second that I get to the point that something is runnable, I'm going to trim the API to the most minimal that I think is reasonable. Um, but I just don't know, like, because I'm not at the point where this is even runnable. I just don't know what's needed and what's not yet. Um, but yeah,
Good.
I think the messaging we're in a good place. I feel like so cool. I know it was a quick stream, but we just thought it would be fun to like hop on and discuss the progress that's been made on messaging so far. So,
It was
um,
really not a planned thing. Maxwell wrote to me, I'm excited for the new envelope thing. I was like, I wanna test out my new headphones. Let's go stream.
yeah.
I think both are great though.
So yeah, hope everybody enjoyed it. And yeah, we'll see you folks next time.
Okay,
Cheers.
folks. Cheers.